So as you know, electric dipoles consist of two equal amount of charges. Let us introduce this electric dipole in an uniform electric field. What is this? This is the electric dipole. If this is the electric dipole of length twice L, so let's say this is the length of this electric dipole is twice L, and E is the uniform electric field. So obviously there is a force on this charge plus Q in this direction, and this force is nothing but Fq, and the force in opposite direction, that is minus Q. So due to which it achieve a torque. So as we know that the torque tau, which is a rotational force for this electric dipole, this is equal to P is a dipole moment, E is an electric field, sine of theta, but theta is the angle between P and E. Okay, so now here P along this direction, the dipole moment always from minus Q to plus Q, and this is the angle, this is the electric field. So due to this torque, due to this force, this dipole will rotate. It will rotate about its own axis. Let us assume that let us assume that the dipole rotates by an angle d theta, So if it is rotates by an angle d theta, so this d theta, we can say this is a displacement, right? So we already learned about the angular displacement in class 11. So now this d theta will be represent the angular displacement. So if it is an angular displacement, obviously this torque will perform some work done. So this work done is nothing but dot theta, right? So torque is a vector quantity, angular displacement is another vector quantity, so the angle between these two is cos of theta, right? So let's assume that they are in a same position or same direction, so d theta, they are in a same direction. So what is the value of magnitude of this tau? P E sine of theta and d theta. So I assume that this is the dipole at a particular interval of time, it makes an angle theta 1 with E, okay, and after some interval of time, due to its rotation, it makes an angle theta 2. So I just consider that theta 1 is the initial angle and theta 2 is a final angle. So therefore total work done through theta 1 to theta 2, so PE cos of theta, which is a negative sign, right? Theta 1 to theta 2. So this is PE minus sin cos of theta 2 minus cos of theta 1, right? So PE cos of theta 1 minus cos of theta 2. You can write like this way also. Okay, so here theta 1 initial position. Let us assume that this position is nothing but 90 degree, and theta 2 final position. Let us assume that this is theta. So if it is so, then our expression of the work done would be PE, so cos theta 1 is 90 degree, cos 90 is 0, and theta 2 is a theta only, so minus PE minus cos of theta, and this is nothing but the potential energy of